All right, so it's the top of the hour here. Thanks so much for joining this session hosted by the Schema.org cluster. The goal of this session is to make some progress on issues in the Science on Schema.org guidelines, but we're happy for the conversation to go wherever this particular group wants and needs to take it. And so we invite you to participate and chime in on topics. Yeah, so I think what we're going to do is just have a quick introduction to the Science on Schema.org guidelines and the cluster at ESIP. And then we'll have sort of three presentations on topics related to the issues that we'd like to make progress on. And then the rest of the time will be for open discussion to progress those issues or talk about the topics that you folks would like to address. All right. So the cluster is an effort that kind of sprung out of an initiative at EarthCube that was seeking to put together guidelines for data repositories to publish schema.org on their web pages. And that was initially driven just by seeing this huge uptick of adoption in web publishing out in the public sector, private sector, commercial sector. And Doug Phils had this great idea that said, hey, we're doing similar things with science metadata. What can we do with schema.org to better describe scientific data sets and data repositories so that this general web search and discovery initiative can find our data sets too? And that was nicely coupled with some efforts at Google when they rolled out their Google dataset search. And so it sort of naturally snowballed into this nice initiative for data repositories who were adopting schema.org, that now their data sets were showing up in this search tool. And so a natural progression from EarthCube space, which was a very limited 6-month time frame, was to bring the guidance documents that were written in EarthCube over into ESIP for broader community comment and work, and to further progress those over time. And so, like I said, we're developing guidelines, and schema.org and structured data for some folk just seems like a huge jungle and a big unknown. And so we really wanted to be sort of trail guides or trailblazers or whatever you want to call us, the Steve Irwins of the animal community, I guess, for folks to help them better understand and just bring the time to adoption, have it be much faster for those folks, and sort of help walk through the schema.org initiative there. And so that was the impetus behind the guidelines, and the cluster continues to do that through education and community efforts, workshops and sessions like this one. And so, schema.org already has documentation on how to implement it. So what's the need for a science-focused effort there? And really, I think when we were all looking at the schema.org documentation, it's very flat descriptions for structures that are really rich and have a lot of connections. And so it's really difficult looking at those flat descriptions, how things are connected and how you should publish. There's limited examples on there. And then there's almost endless ways to talk about things like a data set and a data repository. And so the effort behind Science on Schema.org was really to share patterns of use so that no data repository felt left behind in the space, and that we were all able to publish using the same techniques. And so we did things like drawings and examples, things that didn't really exist on Science on Schema.org. We understood that some folks don't learn just by reading text. Sometimes you need pictures, and sometimes you even need to try things out. And so we really tried to approach all different learning styles here with the documentation. And we've tried to continue that in the schema.org cluster. And so the cluster has been around for a year now, and thankfully in that past year, we've been able to make some improvements on the initial guidelines. And so we released our first revision to those guidelines on April 1st of 2020. And that was over contributions from 7 people, which is fantastic when it would just started out as just a few of us here. And so that was great to see. The cluster is very active, and so we encourage you to get involved there. So I don't want to take too much more time. on some of this stuff, but the slides will be available for folks to look at it later. But just really briefly, we have a release workflow in the GitHub, and document that in a markdown file called contributing if you're interested in just sort of jumping into the GitHub. And then also, we also recognize that in a lot of these community efforts, when you're brainstorming ideas, discussions on very difficult issues can be lengthy and happen over time. And so we adopted this architectural decision record notion to sort of take all these lengthy discussions and ideas, and as we make decisions and changes to the guidelines, just boil that down into a very simple, small document that's published in the repository in a decisions folder that simply lays out like the status of a decision, the context surrounding it, and then the consequences for that decision. And this will help us sort of guide over time, where we've gone and what decisions we've made in the past in case we need to either reverse them or improve on them in the future. So what's next? We're going to have a couple presentations. First up is Amos, who's going to talk about social science dataset concepts. And then we'll hear from Mark Schildauer and Steve Richard and Kai Bloomberg on some dataset variables and how we might describe those using schema.org. And then wrap up with a SHACL validation presentation by Dave Vieglis and Doug Fills. And then we'll open it up for discussion either on these topics or others. So Amos, let me turn it over to you. Are you able to share your screen, Amos?
You have to stop sharing and then I'll be able to.
Okay, great. Thanks.
All right. How's that? You seeing that?
Yep.
I'm getting my browser. I put it in a browser in case I need to jump out here. But so thank you, Matt, for asking me to come and do this. And I have to say, first of all, I'm not a social scientist, so so please take all of this with a grain of salt. I've linked out where I'm over my head. But I do work with a lot of social scientists, and I do have to wrangle a lot of social science data, let's call it that. So what I'm going to do is go through what I've seen, because that's about all I can do. And I'm just going to close my window. Of course, my neighborhood just got really loud. And then we can, if there's questions, I'm happy to address those. So social science, study of human society and social relationships. There's also a lovely Wikipedia definition that looks very similar, which, that's nice, and some semblance of consensus. If you're interested in a list of sub-disciplines, that link will take you here, and you might recognize, some of these disciplines in here. There's a very long list, so I'm probably speaking to people who know all of this, but I just thought I would toss that in there, that although a lot of our work is with, say, indigenous peoples in the Arctic, we are connected with linguists and anthropologists and economists and lawyers and and all sorts of different disciplines that are involved. And our center is very much into this sort of cross-disciplinary research and through, using cartography and geomatics as our kind of linking concept, but really trying to tie a lot of this together. So you're welcome to go and have a peek at those types of disciplines, and I'm sure you can drill down if you're interested. Data definition, I don't know. Being a good, colonial Canadian, I'd go off to the Oxford English Dictionary, but wherever you're pulling this from, I think there is a little bit of difference depending on who you're talking to, but ultimately we're looking at information that we're using for some purpose. Sorry? Oh, I thought somebody was jumping into the question there. But let me tell you what have I seen in the research that we do in an Arctic context is really a wide assortment of qualitative and quantitative data. So when we're seeing data, and even if we're working with an oceanographer, it's being used data is being used by an economist, and then it's going to somebody who's researching food security, and ultimately being used to figure out how much it's costing to catch a fish. And is that changing because the climate scientist is got other types of information? Or it's a climate scientist hearing from an elder about what's happening. And a policymaker may be making use of that information to change, say, the route an icebreaker is taking, so that it doesn't cut people off from their food supply, for example, at certain times of the year. So these are all sort of, human-focused things, but it's not to say that the earth sciences are not fitting into this. They're just being used and using the data that's being derived. Lots of mixed method approaches, so not always sort of one way of doing things, and many researchers will have multiple ways to try and hone in on an answer. Somebody's results is another person's data, so that's that data definition of a data set I think is relevant to this group, and we've been talking about that, and the kinds of things I'm dealing with are things like oral histories, surveys, writings, and you can see the list here. It's pretty all over the place, and I just did a little brain dump, so you get it all over the place kind of the way I do. Interestingly, things like you see place names and places and names. Well, for us, those are three different things, and they're handled differently, and that might not be obvious. There are observations, there are routes, there are numbers, right? We've got statistics, and there's all sorts of recordings of pronunciations, even how things are different bits of languages, and people doing genetic analyses, and there's models, and then it goes on and on. So if you're interested in some of that stuff, and even some of the methodologies and the kinds of data that they produce, refer back to Wikipedia, because hey, why not? And you can look at some of this, and we've had some conversations recently about things like grounded theory and other types of research carried out. And I wouldn't even say that Wikipedia is going to have an exhaustive list necessarily. But what does this look like for us is, it might be something like elders sharing knowledge of place and space, and for example, species that can be found there, when it's safe to travel there, how it's safe to travel there, how things have been changing with the ice over the years, what kind of weather might permit you to travel there or not. Often the goal is to share it with youth, and the scientists are helping to facilitate this, but also to look at that information in new contexts and try to make use of the wealth of basically centuries of knowledge about an area that's been passed down, and that holds quite a comprehensive record. And so this type of information might make its way into a data system, and it could be that it's that sort of qualitative interview type data. It could be that this observational data, in this case hunters, and this device is capturing where they're traveling. They're entering in what they've caught and how many. They are able to use it to report a problem with their equipment, which leads to them getting rescued, but also leads to an economist then asking them how much did it cost to fix, because I need to know what it costs when you go out and hunt a polar bear, for example. What is that? What's the cost? And what's the cost of home? And what about all your people who support you? Maybe they make your clothes, and it goes on and on. So this type of place name atlas is the kind of stuff that we're building, where you might have, in this case, I think over 11,000, but might even be up to 13,000 place names in the Canadian Arctic, and specifically Nunavut and immediate areas, but not necessarily covering all Inuit places yet. But where you can find everything from sort of photospheres of these locations, so you can get a visual of the location. You can have elders telling you all about them, just like we saw them sort of providing to the youth earlier. You can have all of these ones that are outlined in green are actually spoken, so you can hear the pronunciation of the place name, which is really important, because in this case the language is an oral language, not a written one. It might be something like this, a process, and I'll be curious to hear what Pierre thinks about this one. But this is this is sea ice terminology in the community of Cape Dorset for the annual freeze-thaw cycle, and this is sort of being mapped out in a relationships between these and what's causing the divergence in terms and that sort of thing. And there's tons of knowledge buried in those terms. Many of these terms do not have equivalencies in, say, WMO terminology and that sort of thing. So, and they may vary by community to community in some cases because of different phenomena at different places. So language is another one, right? If you want to know different ways to say certain things, you think, well, this is great of interest to linguists, but actually all the biologists are interested in this now because the Inuit have different names for fish that they can only identify through genetics testing. The fact that they're different fish and things like that. So it's there's certain types of knowledge that are quite useful, and it gets into heritage applications and making data available again. And this is a database that's yet to be an atlas that's yet to be launched, but the reports have been published, for individual communities. But a complete inventory from experienced land users, hunters in Nunavut, about where some various 500 species are known to be, and in what kind of quantities, where they've moved from and to, and that sort of thing. And so this is the kind of information that constitutes maybe a data set that I would love to see being able to be included or have at least the option of being included if everyone's okay with it, which is another whole issue, in something that might catalog Arctic data sets alongside ocean temperature buoy data, for example, right? Or climate change data, or ship traffic data, or other types of things. And these applications are not just about trying to get this data set available to science, right? Right? Or we're also trying to make it easier for what everybody else is producing to be used by Inuit. So it's a kind of a two-way street in this case. And so the tools on the consumption side and the searching side and all of that are equally important to us. In fact, for some of us, even maybe more important, so that you can have someone be able to, in a small community, be able to have a way to know how things are changing and how it might affect them, but also to be able to share what's affecting them and what needs to change in policy, like the ship rerouting I mentioned earlier. And ultimately, it means that all the types of science that are going on, ostensibly, not just out of curiosity's sake, but hopefully to make things better for people, that integration will really help to allow, for example, this group of land users and hunters to safely go out, provide for their families, and know how things are changing, know why, contribute to policy processes and all of that. So that's the kind of stuff that we're trying to achieve, and that's why I think it's important for this type of data and the kind of interesting ways that it's created and used. It shouldn't really get left out of that space when we're talking about science or science on schema.org. So thanks. I think people know how to reach me, but there's some info.
Thanks for that, Amos. We appreciate it. That's in the science on schema.org cluster. We're not, while we are focused on geosciences, it's great to hear about the considerations of other disciplines and how that might impact our guidelines. So we appreciate that. Thanks.
And I'd just like to add that I asked Amos to do this largely because at a previous meeting, Amos raised some of these issues about what a data set is and how it is represented in schema.org and whether it applies to some of these social science data constructs. And I thought it was important for us to think as a cluster about whether or not we're taking a very expansive view of data set, or whether or not we're taking a more constrained view. In particular, this concept of things like variable measured was somewhat you know, if you're not using tabular data, if you don't have variables and attributes, instead you have interview summaries and things like that, then what does variable measured mean? And so I think that there are these other considerations we should keep in mind when we're talking about data set recommendations. And I thought having Amos provide kind of an overview of some of the things that he's dealing with would be really helpful to make sure we have that more expansive view of things.
Thanks for the opportunity, man.
Great. Next up is Mark Schildauer, Stephen Richard, and Kai Bluberg to talk about the measured variable on a scienceonschema.org data set.
Thanks, Adam. Yeah, so we're going to tag team this. Kai Blumberg is a PhD candidate at University of Arizona. Stephen Richard is at the EarthCube office, and I'm at NC's UCSB and with the Arctic Data Center and Data One. And this is ongoing work in the schema.org cluster. So the URL there you can see is in the bottom. Adam, next slide, please. Yeah, so the big excitement about schema.org in ESIP is that it may have great utility for scientific data discovery. And in fact, this new property, schema variable measured, really fits right into the direction we want to see schema.org expanding its terms. So it's a property that is intended to be used with the type called schema dataset. But if you look at the little star about what the data set is, and down at the bottom, it's a data set, according to schema.org, it's defined as a body of structured information. So thanks a lot. And as you know, Matt just mentioned, the scope of what you consider a body of structured information, can be pretty broad indeed. For the purposes of the discussion ongoing in the schema.org cluster, we have at least initially focused on sort of like your well-structured data, tabular data, maybe semi-structured data, but we are very cognizant that we have to be very much broader and more inclusive about what we consider to be a data set. I've listed there the GitHub issue. It's the infamous issue 27. You can go there and see various comments, though I think some of the latest issues that have emerged from discussions between Steve, Kai, and myself in the past few days are not yet incorporated. And just to remind folks, our basic operational walking orders were to use existing schema.org terms wherever possible, but also we're commissioned to try to propose new schema.org terms where necessary. Next. Okay, so variable measured. Here's the description of variable measured. It is a property that can be repeated to describe the variables using either text or pairs of identifier and description using property value. And Steve is going to go into some more detail about exactly what that text or property value, what are the implications of that. We just wanted to emphasize, however, that we think variable measured is key to increasing the so-called fairness of data, because through a lot of prior work at Data One and at the Arctic Data Center especially, we've determined that what scientists are really interested when they're looking for data is finding data sets that have the measurements in which they're interested. And here again, measurements, kind of a term that's overloaded. By measurements, think in your head, you might call it an attribute, a variable, a parameter, a field. Just briefly, accessibility, there's been a lot of talk. We're sort of assuming here that it's going to be serialized into JSON LD, potentially exposed into the head of an HTML page, and there's going to be extensive use of dereferenceable HTTP IRIs. We believe interoperability is enhanced because schema.org does provide some consistent semantics, and with that serialization, we get some real nice interoperability value. And finally, reusability, you're going to see that variable measured is where we can actually explicate what was measured, how was it measured, and other considerations like data quality, type, units of measurement, etc. So with that, I'm going to hand it over to Steve on slide 4.
Thanks, Mark. So we have this variable measured, and the way it's defined in schema.org, the values are expected to be either text or property value. And following on the discussion we had this morning about interoperability and making metadata usable across different organizations, one recommendation we would make is not to use the text-only solution. Instead, you can use the property value element, which has a name and description. So instead of putting a free text name or description for the variable measured, implement it as property value and include the name and description there. Thinking in sort of a tiered set of ways that these variables can be measured, the simplest one would be just providing a variable name, better yet, some kind of text description. These would support discovery kind of scenarios. What would be really good, though, is there's a property ID property inside this property value. And one of our big recommendations would be that we should have URIs for property values that can be dereferenced to registries of property definitions that allow providing information about some more of the richness of these property definitions. If there is a property ID and it should dereference, that one other recommendation would be that the name and description should be imported from that property definition to include them inline in the schema.org document, so that the client software doesn't have to dereference the URI to get that information. So it's there in line. Moving along to the next level, next slide, please. So we have these discovery properties. If we want to start thinking about what do you need to know about a variable measured to evaluate whether it's going to serve for your purpose. So this is where we get into some other properties that schema.org has associated with property value. This includes, you can have a text label for the measurement units. You can have a unit code. Right here, this has a code, but this also is another place where ideally there would be a URI that references a unit of measure definition from a controlled vocabulary. Kyle will talk about that in a minute. Schema.org also lets you define a minimum and maximum value for the values in this field. And this highlights one of the issues we have with the way this property value is implemented in schema.org. It's very oriented towards properties that have numeric values. And so we'll talk about that a little bit more as we go along, but that's one point that obviously we think needs some extension. There's also a measurement technique property, which again can be free text or a URL. Then ideally here again, if there was a registry of measurement techniques, let's say something like protocols.io or something like that, that you could reference, that would provide detailed information about exactly how the values for this property were assigned in this data set. That would be a good solution. Value, this property value element inside schema.org, providing a value, gets into what you would use for actual data constructions. Probably not reference, probably not useful. And then they have a value reference property, which has a wide range of possible values. And this could be an extension point for adding more specific information to get into representing some of the deeper complexities of different kinds of variables. And I think Kai will talk about that next. Over to you, Kai.
Great, thanks, Steve. So another thing to consider here is that, as we mentioned, there are quite a few different ways. So I think a really important concept is to get to a dereferenceable IRI or a URI, as Steve mentioned. And then once we get there, that opens up another Pandora's box of what's out there, what do we use, where are we going with all this? And so what I'm trying to do here is I'm trying to just show briefly, and again, there are many, many possibilities. I'm just trying to illustrate and highlight some of these, which might be useful for the purposes of schema.org. And again, it depends on the details of implementation, and no decisions have been made. These are simply just possibilities that have been enumerated to kind of show what could be. And what we can see is when we, as Steve mentioned, if we were to start to further dereference, instead of just keeping everything within the schema block, but if we actually do dereference to other types of controlled vocabularies or other types of semantics like ontologies, we actually get quite a lot more potentially as additional data and metadata. And so just a couple of, regarding units, which Steve had just mentioned, there are a couple of standard ones. This is by no means exhaustive, but a couple of the commonly used unit vocabularies on the web include things like the QUDT, from NASA, I believe, the ontology of units of measure, as well as the units ontology from the Obo Foundry. Now, these all can be used, these all in principle, a system like this could be designed to be agnostic or use multiple versions of these, or allow for the possibility for these to be used. Similarly, we could apply the same idea. Once an IRI has been dereferenced, we could get elsewhere. We could add annotations for properties themselves. So there are, and again, there are a great number of different vocabularies that a few of which I've highlighted. For example, the CF vocabulary, which is used in NetCDF. And there's many others as well. Sweet is particularly of interest to the ESIP community. The NERC vocabulary is very good for the marine sciences. SOSA has also been widely used, and as well as the environment ontology. And so within these will include at the very bare minimum, or sometimes not, can be dereferenced via an IRI. And so I'm just giving a brief example here. You can see with CF, although they do contain a good, sorry, if you can go back real quick. With CF, you can see here in the box next to the arrow, you can see that there's a little bit of information that's being described within the entity. But since there's no IRI, it would be difficult to ingest this quite the same way. And if we go, sorry, if we can go to the next slide, once we actually dereference an IRI, we can actually get more out of our data and join in the larger knowledge graph of, or so to say, of existing data and semantics. And so I illustrated here two examples of ontologies being dereferenced. The first one, SOSA, and also from the environment ontology. And both of these cases, I just wanted to illustrate kind of the same concept. If we're talking about something like a nitrate concentration, which I know is commonly measured within the marine sciences. And so you can see both of these, they contain links to the URI or the IRI. It contains links to an appropriate place on the web where all of this information can be dereferenced. And as you can see, both of them contain definitions and other annotation properties, etc. Another thing that can be noticed, though, too, is that within some systems, like within Envo, you can also have links to other entities themselves. So for example, if I can point you to the equivalence axiom, it might be a little difficult to see, but under the box that says term relations, there's a little box that says equivalent to down there. And what that is saying is it's basically expressing two machine systems that we can actually point to other IRIs to kind of help to have a deeper network of linked information. And so for example here, the nitrate in the environment ontologies, nitrate in liquid water term, links to the chemical entities of biological interest, CHEBI ontologies, nitrate itself as the material under study. So anyway, I don't want to emphasize any one particular thing over another. I just want to point out that there are a variety of, the Pandora's box can be opened once if this were to be incorporated within schema, and we could really make use of existing resources to kind of get to a deeper level of interoperability. So I think I'll stop blabbering there, and I will turn it back to Steve for the next slide.
So we'd like to sort of finish off with some pointers to some of the things that we think are missing in the current variable measured property value content that you can do in schema.org and that are recommended in the current scienceonschema.org guidelines. So one thing would be to have a property that tells you what kind of values are contained in a given variable. And so it could be a simple literal, whether it's integer, decimal, float, text. Currently, the way it's constructed, it's sort of, the assumption is that it's a numeric value, but it also might be links. We talked about structured objects. It might, but also from the discussion we had from Amos, we might also be interested in various kinds of binary objects like images, audio, video, that might be packaged in a data set kind of structure. So a value type property would be useful. The second one is that lots of, as Kai was just indicating, there's a lot of kinds of observations in data sets that have associated context with them that would be useful to know and would help with evaluating the data for fitness for use. And some examples would be things like in environmental data, what biome were the values measured in, what kind of habitat, what sort of environmental feature was sampled, what kind of material was sampled. So there's a need in a lot of cases to know these things. Another property that would be useful would be if a value type is from a controlled vocabulary, some way to specify what vocabulary is used to populate the values in that field. Again, this would be very useful for evaluating fitness for use and whether the data are going to be useful. If you don't know the vocabulary, there's a bunch of work you'll have to do. And then finally, going back to what Kai was talking about, just having some conventions and recommendations for what are useful vocabularies for populating things like unit of measurement and property ID. So these are a few of various issues that need to be resolved, and we're working on making some recommendations for. If we could go to the last slide. There's some links here. One question I'd like to put out there is if people are interested in discussing some of the details here, I think particularly how much content do we have use cases for to justify having inline in the schema.org metadata, as opposed to, let's just say, just having a URI for a property ID that people would have to recognize as being exactly the kind of variable they're interested in. And then going back, repeating again, we have some links here that hopefully will be useful for the Science on Schema.org cluster. There's a mailing list, the wiki page. On the GitHub pages, we have currently there's a discussion around these variable recommendations. It's a document in progress. I'm currently working, the group here is working on an ADR, architectural decision, whatever it is, for the proposed changes. And we invite you all to please have a look at these and contribute ideas. Particularly, I'd like to know, if anyone's interested in a breakout to dive into some of these things. And so with that, I don't know, Adam, Mark, do you guys have any other comments you'd like to add?
Well, that's great. Thanks.
Yeah, thanks so much, you guys. That was great. All right, we're going to move into our last presentation before opening up for discussion. And this is on SHACL validation by Dave Viegelis and Doug Fils.
Hey, Adam. Do you mind if I take the screen?
Yes, I apologize. Yep, go for it.
All right, thanks. Let's see. What's this one? Okay, so I'm just going to talk a little bit about programmatic evaluation of guideline conformance. So the Science on Schema.org group is developing these, putting together these guidelines, which are very nice textual descriptions with examples and nice diagrams and so forth that provide guidance on recommendations for implementation of schema.org in JSON LD that's embedded in web pages to describe data sets and catalogs. Having these guidelines is super useful. Of course, there's lots of different ways you can implement this metadata. But one of the big challenges, of course, is verifying that you're actually, what you're putting together actually matches the guidelines. So we want a mechanism to test the JSON LD versus the guidelines. So the tool of choice for doing this in the RDF world is this shape constraint language, which is relatively recent, it's a few years old now. But it's basically a language for validating RDF graphs against a set of conditions. And those conditions are themselves expressed as an RDF graph, and the output is a validation, what they call a validation report. That's also an RDF. And so you can see the process is pretty simple. You have the inputs on the left-hand side here, which includes the SHACL shapes graph. The data graph is like your JSON LD that may be in a web page or whatever. Then optionally, you can include an ontology graph, which provides things like the class inheritance relationships and other information about the data that you're trying to describe. You run that through a SHACL processor, and out comes a what's called a validation report graph. So conceptually, it's all pretty simple. It's just a very simple workflow. So what are the pieces needed for this? Basically, we need to take the guidelines and express those in SHACL rules, SHACL constraints. And then we can take data, which may be in different locations, or maybe just files on your desktop or whatever, and run that through a SHACL processor to get the validation report to verify that what you're looking at actually conforms with the guidelines. So that requires development of these guidelines. It also requires some tooling to provide this SHACL processor part, and then also some rendering of the validation report that comes out the other end. There's quite a few SHACL processors out there in varying degrees of completeness. Top rate, and there's this, the W3C has this conformance testing framework, which evaluates various implementations of SHACL processors, which you can take a look at. You can see that the top rate, see there, the top rate composer implementation, it passes, basically the reference implementation for SHACL processors. It passes all the tests. PySHACL is very close. It's currently failing, I think, 1 or 2 of the more complicated tests. And there's various others that you can work with as well. Okay, so we've taken PySHACL, and this is work that's really building on the Tangram system that Doug Phil's put together a while back, and Adam Shepard and a few others on Project 418. And basically, I've worked with the Tangram application and tried to build a system or tools that enables relatively easy validation of the work. And so basically, we have the tooling in place now, and there's 3 basically different types of implementations of tooling. One is the command line tool, which is very useful when you're developing, in particular, the SHACL rules themselves, because what this does, it'll watch for the files on your local disk for changes and rerun the rules every time that there's a change. So it's like an interactive editor for, that makes it much quicker to develop the rules and see what's working and what's not working. There's a browser UI implementation that's running on Amazon AWS, thanks to ESIP for funding that. And there's also a little browser extension which lets you look at the JSON LD that's embedded in web pages and send that across to the AWS service for validation and so forth. And I'll show a quick example of that in a little bit. So, SHACL is not, I wouldn't say it's terribly widely used, but it is used by some big players, and especially in e-commerce and even the legal world, in ELI, European Legislation Identifier frameworks. They've made extensive use of SHACL, so that basically all these legal documents that are being provided from different members of the EU, they all conform to SHACL shapes, and so they're very easy to ingest and process into various systems. Similarly with this e-business interoperability testbed, there's a lot of activity that's ongoing in health records for sharing information between institutions and between different instruments and so forth. This implementation by Netage is really interesting. It's for fire departments, and it's basically a system that could be implemented by or deployed by municipalities, large groups, which manages spatial data and forensics data and current real-time traffic and so forth to help fire departments really efficiently deal with fires. and the various, you know, controlling the risks associated with that and minimizing expenses and so forth. It's really a very interesting application. Anyway, they use SHACL to verify that the content coming from the various sources that they use conforms with the requirements of the ingest of the workflow system that they're using to ingest all the content and run, you know, like machine learning algorithms and so forth against that. So it's a pretty cool system. This dash data shapes is another thing together by Holger Newblock, which is nice because it's got actually a SHACL, this /schema thing on the end there. You follow that link, that's actually a SHACL representation of schema.org. So you can actually apply those rules to basically do the same thing as, kind of the same thing as what Google structured data testing tool does, except using SHACL instead of whatever Google does. All right, so what does it look like? A validation report is what comes out the end of the SHACL processor. And if everything passes, then it's pretty simple. You basically get a Boolean saying it's true, that it passed, that's valid, and 0 failures. We ended up having to add these 2 additional extensions to the report because, as I'll show later, it's really easy to produce a report that doesn't actually do anything, and you don't know that it doesn't do anything. And so we added in these counters, which basically keeps track of how many rules and so forth have been applied to the data as the shape graph is applied. These have actually been taken by Holger to formal extensions, which are now expressed in the dash data shapes vocabulary. So hopefully soon tooling will catch up with that in general, and there'll be much better reporting capability that comes out of SHACL. For a non-conforming report, you get potentially a huge amount of information coming back, depending on how the constraints are written and how the documents are structured. In this case, this is one failure that we found where the name was missing from the data set description. And so you can see there's a min count, constraint violation. And you can take this and re-render it into something that's a little bit nicer to read. What I was talking about before with these extensions is really important because in this case, the SHACL rules were applied against a data graph, but within SHACL, there's this notion of targets and constraints. And the targets specify things that must match within the data graph for the constraints to be applied to. And if the targets don't match anything in the data graph, then the validation report returns true because everything passed because none of the rules got applied. So having this number of shapes applied value in the report is really super useful. Just quickly show a demonstration now of this Chrome extension. What this does, so there's JSON-LD embedded in lots of different pages around the place, web pages. And it's normally opaque, it's hidden away in the background. It's used by content indexes and so forth to get a structured view of the content on the page. Then this Chrome extension, this Tangram Chrome extension, detects the presence of the JSON-LD in the page, and then basically extracts that and lets you do different things with it. So in this case, this is a type of a news article with different links and so forth that crawlers can ingest and do something with. It's not a data set, obviously, and not a data set description, but it just shows that JSON-LD is used more widely than just for data sets. Here we have an ARM page, and clicking on this, we'll see that there's a data set type in there. And when the tool detects that there's a data set in the JSON-LD, it'll send that JSON-LD, that data set metadata across to the web service running on AWS to run the validation report using the SHACL rules that have been provided by the that are coming out of the Science and Schema.org group. In this case, we see that this particular thing failed. Now, if we look at it in a bit more detail, the UI is pretty bad on this, but basically down the bottom of the page in the least expected location is the validation report. And we can see here that the minimum constraint is violated. In this case, the path says that it's the version property that's missing. Okay, so we can go back up. And this is integrated with the AWS service, so you can click on edit, and that'll send the JSON LD across to the web service so that you can then interact directly with the JSON LD to do things like, in this case, we're going to fix that. Oh, before I do this, let's run the validation. You can see version's missing, so we'll just add in version and see what happens. Let's make something up. Okay, so now the validation report passed. So now, if I was working on implementing this on a website, I could take this knowledge back to the implementation and just add in the version thing. And then we know that the JSON LD metadata describing the data set is passing the guidelines that we have in schema.org. The tool basically automatically detects stuff. So if you just go to a random page, here, maybe in Pangaea, you can see that when it finds something, there's a little couple of numbers that show up. The first number is the number of JSON LD blocks in the page. The second number is the number of data sets on the page. Again, you can click on that, data gets sent across and validated. Here you can see there's a couple of properties missing from the Pangaea content. One of the interesting challenges was making this work with single page apps. So in this case, the Data One search interface, it dynamically generates the page as you're navigating. And it's kind of tricky sometimes to detect that things have changed. But thanks to some recent innovations or adjustments to the JavaScript language, we've got what's called a mutation observer implemented in the tool. So it automatically detects when JSON LD appears in the page that it's looking at. And here you can see that there's a single violation for this particular page in Data One. I think that's all I want to say about the tool. It's definitely a work in progress, but I find it quite useful for exploring implementation of JSON LD in different pages and being able to access that metadata easily to like cut and paste into other places and so forth. So just continuing on a little bit, the big challenge with all this is, now that we've got some fairly okay tooling to work with the rules and data sets and so forth, the big challenge remaining is actually implementing the shapes graph itself, the SHACL constraints. This is kind of what they look like. It's really conceptually fairly simple in that you specify targets. In this case, the target is a class that matches. So this will match any instance of a data set that may appear, in the JSON LD. And then this basically just says that there's a minimum count of 1 for the main property that should appear within that data set. Obviously, they get quite a lot more complicated than this simple example, but the basic notion is that you have targets and constraints. There's lots of different ways of specifying targets and constraints, of course. You can specify a particular node, a class. The node has to be, part of the graph has to match a particular class, be subjects of, or objects of. And if you run out of options there, then you can use Sparkle to specifically identify targets within the graphs. Similarly, there's a whole bunch of different types of constraints that you can use. It's best to take a look at the documentation, which has a huge number of examples in it. So it's very approachable documentation. And it's also really helpful to have the tools that you can interact with dynamically as you're applying these, developing these shapes. So the current status is there's a branch, feature branch 59 SHACL, which includes the version 1.2.1 of the shape graph. It's pretty limited in its coverage right now. Of course, we've been spending a lot of time on tooling to make that efficient, to ensure that it works effectively across the different sources of JSON-LD. And so now it's time to really dive in and sort of keep adding to the SHACL rules, which basically should mirror the guidelines. So anytime we produce a guideline or a recommendation, we should also produce SHACL constraints that are able to test that guideline. But we should also provide test cases that are both positive and negative tests for that as well. So the green pieces here, they're all implemented satisfactorily in this shape graph. The blue are in draft form, actually on my laptop when I need to move them across. And these other pieces, I'm kind of waiting on some of this to stabilize a bit. But in most cases, these are pretty straightforward to put in now that we've got the patterns of implementation pretty much sorted out. There's a bunch of resources out there for working on this stuff. Of course, scienceonschema.org is the main location where all this is housed. I've got a fork of Doug Filsey's copy of Tangram, which has some added pieces to it. We need to sort of merge that back together again. This Chrome extension is also available on GitHub, currently in my place. I've submitted it to Google for inclusion in their web, whatever it is, web store. I got word back yesterday that it didn't pass, but it didn't pass because I didn't include enough screenshots apparently. So I resubmitted it, and so hopefully it'll pass. SHACL is well described here with a W3C. JSON-LD, it's worth reading through the specs for JSON-LD because there's lots of interesting pieces, at least that I learned about JSON-LD that I didn't realize you could do. And the SHACL Playground is also a really nice place to get to know how to interact with SHACL. That's using a top-grade implementation of the SHACL processor, but it's a JavaScript implementation, which is nowhere near as feature complete as the other implementations. And some other keywords to look for are, to Google about PySHACL, RDFlib, RDFlib JSON-LD, and Extruct. Extruct is a nice command line tool that enables easy extraction of JSON-LD from pages. All right, so that touched on a lot of stuff at a very sort of shallow dive. I think now that we have like the tooling and the start of the SHACL description available, it'd be great to have a few folks that are interested in contributing to this to dive in and sort of help build out some of the shapes to more fully encompass the guidelines. And that'll provide a tremendously powerful resource for implementers to verify that their content is actually matching the guidelines. And I think that's about it.
Great. Thanks so much, Dave, for that presentation. It's great to see some tooling in this area, and it gives us an opportunity for folks that don't quite know schema.org all that well to have some way to sort of test their results. So that's fantastic. Thanks so much to you and to Doug. Great. All right. I think now I'd just like to open it up to the rest of the group for discussion. There was a bunch of really great questions in the chat, so we could start there, or if someone has a question for Dave, we could also take that now. Or...
Yeah, sure. I got a question for Dave. Hi, this is Blake Regalia. I have, we've worked with SHACL a bunch in the SDK lab at the Department of Geography at UCSB on some research projects working with Siemens, and I've also worked with SHEX more recently, and just wanted to I'll post a link in the chat about the differences between the two, but ultimately I've sort of been converted to the SHEX camp. It's I find it much more like intuitive and user friendly to write shapes. And they are somewhat complementary tools, I would say. But like for most of the workflows, in terms of like the thinking about the people or the engineers who are coding these shapes, and really like turning these requirements into rules or expressions, the interface is just much more intuitive for them, I find, with SHACs. And I also find that the tooling is much better supported in like the SHACs community because of how kind of more like flexible it is with validation. And also the results that you get are quite different. Again, they sort of fill different complementary tasks. So just wondering for your use case, if you evaluated SHACs and you know, what decision, factors influence your decision in that case.
Yeah, thanks for bringing up SHACs. It's, the decision from at least my perspective came pretty early on because I was really just learning about both SHACs and SHACL. And, from my perspective, I pushed SHACL primarily because it was a recognized standard in W3C, which I believe SHACs is still like a draft, but I could be wrong there. I agree that they're very complementary technologies. I can't give a good functional reason why I chose SHACL over SHACs. It's just the path that we ended up following, and a lot of the tooling that we have in place now could actually it'd be pretty easy to convert or put in parallel support for SHACs processing as well. Because the main part of the work is basically having the JSON LD extracted and sent to the processor for validation. The big challenge would be, though, I think developing the shapes and guidelines. We've made this start with SHACL. If we can do complementary work in SHACs, then that'd be awesome. Or even if we switch over entirely to SHACs, that'd be fine too. I think the main thing that we want to get to is, just being able to programmatically test and verify that the guidelines are being adhered to or being used by different groups. So that's the main thing. I'm really I don't have any particular preference for either technology. As long as
yeah. I'll just say then to everyone else who's listening to really give SHACs consideration. The history with SHACL is a little bit political too. That was mostly developed by Top Braid, and then so they were very ready to just create the W3C recommendation, and so they sort of beat SHACs to market. And then there were two sort of teams that were collaborating on this one idea, and then they sort of split because they have somewhat different philosophies, and so that's why we now have SHACs and SHACL. But I would just urge everyone to really consider the differences between those two if you're thinking about using shapes and expressions, which I think plays a huge role in all across the industry these days, as a lot of companies and organizations are sort of looking into everything knowledge graph sort of, and how they can validate their requirements, so to speak. So thanks, Dave.
Adam, can I ask a question? It's Peter.
Yeah, absolutely. Go for it.
Thanks, Dave. I think this is great work. But I want to ask a question because I think I might have missed something along the way. Might be for you, might be for Doug, might be for Adam. Last year, we were talking a lot about sort of schema validation based on Google feedback of coming through the tools that Google was providing. And now it's nice to see you've moved to a rule-based SHACL service, which I think is great. But who are the rules created and approved by Google? Are they still going to pass the Google Dataset search criteria, or they're just going to satisfy the SHACL rules and thus might they ultimately fail. And this is something for schema science on schema.org, I think, because SHACL rules are coming out of science on schema.org, and so you're sort of taking this authority, which is great. But is that this last kilometer connection back to sort of the ultimate, if we like, implementers of the discovery capability? And if I missed something, just please correct me.
Yeah, it's an interesting point. So one thing to keep in mind is that the Google tools are put forward by Google to verify that content can be indexed and accessed by Google. You know, they're obviously thinking a little bit broader than that. At least from my experience, the Google validator is very loose with what it considers to be valid content. So content that may be valid for Google won't even pass in a RDF processor. So it decreases the accessibility of that content potentially if you're just relying on the Google validation service. In general, I think there's nothing being proposed in the Science on Schema.org group, at least that I'm aware of, which steps outside the structure of Schema.org as expressed by their vocabulary and ontology. And so as long as it's valid within the Schema.org vocabulary, it should also be valid within the Google structured data testing facilities. So in general, I think the SHACL rules that we're developing will be a more tightly constrained representation of the rules than would be expressed in Google. And if anybody else has some opinion on this, please chime in.
So that's really cool. That's a great step forward. Congrats to you guys.
So Adam, I think you posted to the Slack channel recently about the changes in Google's validation tooling. And we had a little conversation about that too, right? Which I think impacts this conversation.
Yeah, that's right. So I think Google is deprecating their structured data testing tool in favor of their rich snippet tool. And so I just ran a quick test against a data set just to make sure that that rich snippet tool would at least give us the same feedback that we were getting from structured data testing tool. And that is in fact true. So that's a good sign that at least we haven't moved backwards with respect to Google and testing capabilities there. Happy to share that link too if folks want. I'll throw it in the Google Doc.
Thanks, Adam. Missed that thread on Slack.
Yeah, please do post that link, Adam. Thank you.
Adam, I might mention one other thing here along these lines as well. Is I did actually just hear back from Dan Brickley, kind of commenting on this a little bit, and I was asking him in particular if the structured data testing tool or its replacement aligned with the capabilities and features of the Google indexing bot itself. And one of the things he said in that response was that they are looking at routes to close the gap between what we can expect from Google tooling and from others in the ecosystem. And this includes evaluating SHACL, SHEX, and Chrome Lighthouse as possible deployment routes for open source validation. So just wanted to share that. And he said there's probably more to share on that later in the summer, early fall.
That's great.
Can I ask a question to Steve or to Kai? Maybe to Steve.
Yep.
As you know, as we commented in the chat, the similarities between what you proposed for parameters and the ISO standard that's been an international standard for a decade were remarkable. A couple of things that I didn't notice, and I just want to know if I missed them. Can a parameter have multiple names that come from different sources? Because I think that's super critical. I mean, we see that in NetCDF, you know, variables have standard names, non-standard names, and long names. And having standard names from multiple places is really important. And the other thing is, one thing that we had in ISO was the coverage content type, which allowed you to differentiate between physical measurements and model results and quality information and reference information, which is really useful in a data set where you might have hundreds of variables, to be able to say, show me the quality the variables in this data set related to quality, or show me the model results or the reference information. Could be latitude and longitude or whatever, right? I think both of those things would be really critical for a reasonable parameter metadata model.
Interesting. I mean, right now we're using the schema.org name field for the variable name, and it, I believe, would allow you to have an array of names, but really I think for the use case you're talking about, what you really want is something like a scoped name, where you can have a name and the context in which that name is used. And as far as I know, there isn't such a construct in schema.org. As far as the coverage content type, I didn't get into that detail, but that is, one of the complexities of a lot of kinds of data. I mean, from talking with Mark Schildauer about the various environmental data sets he's dealing with, is in a lot of cases, I think we have this analogous situation where, there's in let's say just in a tabular data set, you can have columns that actually contain information about attributes in other columns, the quality kind of information, uncertainty, even units of measure. And I think that's analogous to the idea of in a coverage, right, where you have, I haven't worked that much with coverages, but you'd have some kind of layered structure where one layer or grid would be a quality overlay on another layer, right? And so you have to have linkages between the variables. And we haven't gotten to that level of detail in terms of even beginning to think about how you can't do that with schema.org the way it is now. So I think the open question is, what's the best way to capture that kind of information if you need it? Is it better to link out to some other resource, some SOZA or some other kind of RDF vocabulary that has the capability of representing that kind of stuff? Or do we try to actually put, in schema.org, it's open, it's RDF, it's open world. We conceivably could also have a convention where we say, use this vocabulary and put those details in line using some other like DataCube or something like that, which I think would let you do that.
Yeah, it looks like Pierre has some ideas too that might be interesting. But yeah, the relationships between variables, sort of goes beyond sort of the question that I asked. But yeah, it's really important. In working with some of the airborne chemistry data collected by NASA and others, there's a ton of relationships between variables that are really hard to capture even in ISO.
So Ted, I think that your point that you bring up about the ISO comparison is really pertinent, because it does bring up the issue of what we're trying to achieve here through schema.org. And there are clearly much more detailed vocabularies that already exist and are in widespread use across the metadata landscape. And I think variable measured up till now, like most of the stuff we've been focusing on in the schema.org guidelines have been really high level, kind of discovery level metadata that's meant to make it easier to have interoperable catalogs across groups that use different dialects and different systems, and that let groups like Google that have no interest in diving into the details get into it. But as we get into variable measured and we start to get into some of the structural characteristics of data sets, then we start to have a lot more overlap with those existing vocabularies and what they do. And so I think we need to ask ourselves the question of what we're trying to use the schema.org markup for, and how much it should replace versus just supplement the existing vocabularies. Dave and I have talked a lot about trying to make sure that the schema.org record has a linkage back to existing metadata documents in those other vocabularies in a standard way, so that if somebody has already a really detailed ISO document, that should be a prominent feature of the schema.org markup, so that we can then trace that and not necessarily have to repeat it in the schema.org itself.
Yeah.
The disadvantage of that is it's less accessible to these graph processors and stuff like what Dave just showed. But nevertheless, we do have, I think, kind of a use case analysis to do and to think about what it is we're trying to get out of this top level schema.org description on the landing pages.
I think that's a really good point, Matt. It's really important that could be something we have some breakout discussion around is what is schema.org for? How deep do we want to go and where do we start linking out to these other things?
Yeah, and I mean, we added that capability to ISO in 19115-1, and the reason we did it was because a number of people were interested in translating to ISO from some other dialect, and whenever that translation is incomplete, you need a link back to the original metadata. And that also exists. Another case where this is used is in Dataset, where Dataset has a related identifier, which is has a relation type of is metadata for. So you have a data set described in Dataset in their schema, and then it has a related identifier, which is the more complete, scientific. I would call it scientific metadata instead of discovery metadata. And the other place where this is important in quality, ISO has a coverage type for a quality report where what Steve was just talking about, where you've got a coverage, which could be a grid or it could be a time series or it could be a line, and you've got quality either as another grid or another time series, like you mentioned, Steve, in the tabular data. And then that's a coverage. That's a coverage quality report.
So I'll say one of the things that I like about using schema.org that I think is it's sort of a stealth path into RDF. So it lets us become more formal and create an extensible graph and gets us out of the XML world without people having to deal with RDF in its native form. And so I think it lets us sort of span these two kind of communities of practice on how to represent metadata in ways that we have, I think, struggled with over the years. So there is some benefit in my mind to exposing some of the stuff like variable measured up at the schema.org level, because it does kind of give us that gateway into a graph world of viewing things. So,
I think the names, exposing, I mean, I agree with, I think it was Mark, who said, scientists are interested in specific names of things. And of course, then you get into the, parameter naming problems that, have been around for a while, but exposing those parameter names or even classes of, groups of parameters, I think would be really important in schema.org. And I think that's specifically why you probably need multiples, because you want people that are searching for names of the same thing with different vocabularies to be able to find it.
I think that's a really good point, because we're struggling with this in looking across data sets, across disciplines, and different disciplines are already using different ontologies and pointing at different repositories like that, and so, or if we're lucky, and so being able to have that path to be able to say, oh yeah, I do have some data that fits and I want to describe it, and I'm using CF conventions because I'm dealing with bottle files from some ship, and that's great, and it's all netcdf, and off it goes. Other stuff might not fit with that. The climate and forecasting won't work for some other types of data sets. So having that ability to do that and do that at schema.org level and have it be essentially optional to describe at that level. So we don't exclude people who aren't going to take those steps. But for people who do, they can. And if they want to go even further, they can point to something more formal like their ISO records or whatever. Anyway, yeah.
Yeah, Scott Peckham's not, I haven't seen him around. I don't know if he's here. But his work on names, I think, is really some of the best, because it's really names, and it's fits into ontologies very nicely. Names that are created using rules instead of names that are created by committees who can be very slow, like the CF cartel is very slow in general, but I point you to Scott's work for names.
So Adam, we have about 10 minutes left, right?
That's right, yeah.
So how do we want to kind of I mean, obviously there's a lot more discussion to be had about variables measured and that work, the SHACL work. We had another topic on the agenda to talk about the OWL time, I think, and temporal stuff. And so clearly all of that stuff is we're gonna need more time to dive into that. Should we just wrap this session up with kind of trying to get general feedback about these approaches from folks and then invite people to the calls, or how do you want to?
Yeah, I think that's a good segue. So this is ongoing work. The cluster meets twice a month, which is a little unusual for other clusters, and I think that's to have times that accommodate some folks in Australia that participate and also in Europe. So please, I mean, if you're interested in this effort, learn more about what we're doing at the GitHub repository and participate in the telecons, or just chime in on the GitHub issue queue. I think all the topics here are great. Schema.org is something that obviously with a mind for Dataset has to think about not just geo, but all types of data sets. And I think Amos highlighted that. But I think there's a lot of work that we can do within the given schema, but also working with folks like Dan who are connected in to our GitHub repo and have active connections to folks in the group where we can get some changes made. So please feel free to participate if you're interested.
So do folks have further comments on any of those sort of focal areas for the 1.2 release we're planning, which focuses on variable measured and temporal representation of things like geologic ages, as well as some of the validation stuff that Dave had in the list that Adam has in the agenda?
This is Ruth. My only comment on that is that I think we need to think of this in two streams. What is a general, recommendation, and then potentially what are the, profile versions of that, more specificity. Now, I understand the need to work with existing vocabularies and things like that for parameters. I'm hoping we can, in the time and space realm, pick one of the many different options and move forward.
Do we need, Ruth, do we need to pick one? I mean, when there are so many available, like if there's, they service slightly different communities, wouldn't it be better to kind of have a more federated approach? Like say, here are different ones that we adopt and then write in the appropriate code to address their use cases? I don't know.
So the use case that I'm specifically talking about is a generalized discovery across all types of data, including oral histories and such.
Yeah, I think that's the long.
And if you can argue,
that's a long-term goal, but like we have to, that's like asking. I don't know. I suspect that might be asking for too much right away. Like we need to build to that. We need to link up what's there and slowly let the work come to a point where we actually have everything. I mean, that's like you kind of sound like you're saying like we need the knowledge graph for the universe like now, which I mean maybe we need it because the climate's collapsing, but like realistically, I don't think we're there yet.
Well, okay, so the problem I'm facing is that if you let people go off and implement too much, then you get so divergent a set of things that you can never do any kind of federation without hand tuning everything. And that's been the history for the last 30 years, really. And the issue here is if you can get up in front of that and make some operational decisions that your minimum, metadata to play in the XYZ Federation is this, and you're going to implement it that way, then you can actually implement it. Otherwise, these little, places that just have a web page and no technology people other than their web person that they might hire for a few thousand a year, aren't going to be able to play. So I'm talking about inclusion here, really, of communities that have been left out of these conversations now for a long time.
I think you two might be talking about the same thing, but a different approach. And I think it's helpful to, as a tool builder, obviously the more varieties you have to support, the more likely it is that you're going to leave off the ones that you don't care about and not necessarily spend the resources to support that. So if somebody said, hey, there's 6 different ways of specifying time in schema.org, and 80% of the people are using this one, as someone else pointed out, it might just be necessary for people who need to use their specific ones to maybe also, if they want to play nice, include the dumbed down or simplified version for that discovery level, where maybe we can get more commonality, so we have more people able to make tools at that level that support everybody as opposed to just their niche. I don't know, but I think there's a risk of saying, well, owl time can do everything. Let's use owl time, and then it requires 15 lines in your in your metadata to describe last year.
Yes, exactly. And I think you're actually making my point much more eloquently than I did. So thank you.
Adam, this is Peter. I tried to raise my hand. I pretty commonly support Ruth's position on this, but I'm going to make a suggestion for what this cluster is doing, because I think this is science on schema.org, and that what I often see, and not pointing at you guys at all, but I see it in a lot of places, come out with an implementation, a version, a recommendation, and then you don't see what we left out and why, and what else is in consideration. And what happens is what Ruth said, exclusion happens, and people go off and do their own thing. And the ESIP way really is a much more inclusive approach. It's to sort of be more descriptive. It's like, hey, we thought, low-hanging fruit, dead fruit on the ground, whichever way you want to think about it. Yeah, let's do ISO 8601, or let's get brave and do owl time, or let's do non-Gregorian time from Simon, Cox, and Steve, Richard, and others. But describing that in a more narrative way to sort of let people know maybe what the roadmap is. It's like, oh, this year we don't have it, but if you've got this type of data, oral history data, where you record it one time and it's about another time, that could come in the future. And what it does is it includes people, entices them to be part of the conversation, knowing that they're going to have a voice, they're going to have a use case. So I just want to, put some weight behind what Ruth is saying. You have a great, I think, this cluster is fantastic. So much happened, so much progress, so much good stuff in a short period of time. Just want to encourage this sort of more inclusive and more dialogue-y type approach.
Yeah, thank you so much for that comment. I really take that to heart. I think what Ruth is trying to do with the Polar community is fantastic. And I think earlier today, she came up with a really great idea of how this might get accomplished within the cluster. But I think we've tried to encapsulate some of our conversations in these architectural decision records, but I think maybe we need to take it maybe a little step further, Peter, to make sure that the language that we're using is a little bit more inclusive. So I really appreciate your comment.
Yeah, and hang on, you guys are all tech heads, right? So you use architectural decision records and GitHub issues, and you could write a blog. You could write. You could do something really simple and use, I don't know, what's that called? English. And
Peter,
sort of
you keep saying you, but how about you?
I will help. I will
Okay.
absolutely help. I am not tossing it over the fence. I will absolutely help. And in particular, when it comes to the time issue, we've done a ton of work on time over the years. The fact that no one's mentioned concave and convex time for discovery is telling to me. So I'd love to know, and I don't know how I do, I probably need to sign up to a different Slack channel when that convo is going to happen at a telecom, because I'd like to put in the stuff that we did, 6, 8 years ago on this, and limitations in our time and all this stuff. I will be a voice, absolutely. I'm not, yeah.
That's great. Thanks. I think Ruth, even in our GitHub issues, has echoed that same sentiment that the language that we use is a little too techy. So hopefully we can get more folk in with voices that can translate our technical language here. So I really appreciate that.
Yeah, Adam.
I'll just,
Right,
here, I'll just,
oh, sorry, Matt.
sorry, just let me,
Quickly, when is the next meeting? Just so people are aware.
Oh, you think I'd have that queued up here. The next meeting is July 23rd, which is supposed to be next week, but it's probably during ESIP. So I'm going to say the next meeting is August 3rd, Monday, 5 p.m. Eastern Time. We're the first Monday and the fourth Thursday. You can check out the ESIP calendar. I'll make sure that the links to that are in the Google Doc.
Peter, I just put in a link in the chat to a Slack channel for ESIP, where there are a bunch of people interested in the time question and how to represent peak time and stuff. So that's of interest.
That's cool. Thanks, Matt. I'm going to subscribe right now.
Thanks, folks. Well, I think we're a couple minutes over time here. I'm not sure if we need to shut down or not, but if we don't have to, you're more than welcome to stay.
Yep, Adam, we don't have to. If somebody wants to take over being the host, I can make that person the host and this can keep going. Anybody?
I don't mind, Aaron, if you want to just make me host so you can leave and then
Awesome.
I'll wait for stragglers.
Okay, that sounds great. Thanks, Kai. Thanks, everybody.
I just throw one thing out, since we're going to be at this ESIP meeting for a few more days, and there's so many people in these breakouts, in these sessions. It's wonderful. But if you guys can look at your Zoom preferences, or you people can look at your Zoom preferences and throw a picture in there, makes it a lot easier to tell who's here and who's talking than all this reading all these names. Of course, if you don't want to do that, that's fine, but it happens in your Zoom preferences, is where you put in these still pictures, like this great picture of Jeff with at the Grand Canyon. Anyway, that's just my for someone who's a visual learner, that would be great.
And then one more thing, Aaron reminded me to remind everyone that there will be a plenary tonight in 30 minutes. So if anyone is possibly available to attend, that would be awesome.
Great. Well, I just want to take an opportunity. Go ahead.
Adam, I was just going to say thanks. I thought this was a great session. I learned a lot.
Great. Well, thanks, Ted. Thank you to all the presenters and the folks that got this cluster started. Peter Fox, who initially brought up schema.org way back when. So, this has really been a continuation of his topic here. So thank you for letting us take the reins a little bit. All right, folks. Well, we hope to see you at the telecons and at the rest of ESIP summer meeting. You're more than welcome to stick around here and chat more about schema.org. But thank you for your time today. Appreciate it.
All right.
Good job, Adam.
Thanks, everyone.
Thanks, Adam.
Thank you, Adam, again for hosting and organizing this committee. So we really appreciate your work.
Yep, indeed.
Woo!
Indeed. Bye, guys.
Bye.
Thank you.
Bye.
So I'll just keep this open for a bit longer in case there were others who wanted to continue any other conversations.
Yeah, sounds good. Matt, I probably should have thanked you. We wouldn't be here if it wasn't for you submitting there at the 11th hour. So
No worries.
props to you for getting that on the schedule. Man, you're kind of freaking me out wearing a Patagonia jacket in the middle of summer, though. What's going on over
In
there?
Alaska. What are you talking about? Yeah. So I guess one thing that happened last year, we spent a lot of time last year in between sessions working on moving proposals forward and kind of just dedicating some time to things. I'm kind of wondering if there's an opportunity for that here as well, or whether people want to just basically revert back to the calls to try to move forward. Like, we didn't get really into the details of variable measured. We didn't really get into the details of some of the other issues that are open and that I think we've needed discussion on.
Yeah,
it was a great introduction to all the topics, but not necessarily any resolution to them, right?
Right. Yeah, I'm certainly game if folks want to.
Yeah, I think we dropped some of the folks that are leading some of those things. I think I saw Mark and Steve both drop off. So
yeah, Kai, can we put Kai on the spot and ask him if in their discussions whether they maybe had a consensus on a generic model that might fit for variables?
I mean, I think we're working on it. We're kind of just trying to show what could be. I think it's going to take just more time to actually pin these things down. There's a lot to consider, but I mean, I can ask them to jump back in if you want, but anyway, the point being though that I think that what I think they were trying to highlight was that within those you could use the ID property or whatever those are called values, and then if we link that to an IRI, we could get more out of it. That's kind of the take home there. How we pin that down and what we do exactly, I don't know. I'm also I understand Ruth's point of like wanting to set standards and be like, do it this way. And that's probably a good idea. But on the other hand, there's just so many disciplines. Like I worry that like trying to have a one size fits all solution for so many different communities, data sets, repositories, there are vocabularies for some, not for others. They're high quality for some, less for others, etc. Like I know that on the back end, like a lot of that stuff isn't ready. Some of it is, and it's servicing those communities well. Some of it's not. So I think I understand there's an urgency here, but I also worry that like just kind of pushing a solution right now that's incomplete might, in the long run, hurt in some ways. I'm sure it's beneficial in others though. So I don't know.
Hi guys, this is Rob. I just wanted to echo what Kai just said. If I may.
Great, thank you for chiming in here.
Yeah, from my perspective, I think Kai is correct that trying to have just one resource, either at this stage or in general, may not be the best approach, since there are a variety of resources out there in all things. So, for example, picking just one, let's say, one control vocabulary, or picking just one ontology for a given subject wouldn't do justice to, let's say, the various projects internationally that may have others, their own sort of rendition or their own sort of modeling approach for that particular subject. And it's also sort of a question of, ethical considerations, right? So being inclusive and neutral for the various resources that are out there. That's just my 2 cents. Yeah.
Yeah, but I think we should separate out the choice of vocabularies from our recommendations around what kinds of information people should be providing. Yeah. This is a very deep area, right? We've been talking about it literally for 15 or 20 years, how to model, these data systems and observations and measurements. So there's a lot that could be done there. And I think we want to avoid falling into the trap of trying to create that perfect model before we push things out. Right now, the guidelines basically say provide a name and you're good to go. And that name can either be in the form of a name or possibly an IRI. I think if we could refine that a little bit and say, this is, it would be really great if your IRI conformed to an observations model, or if, there's probably some small tweaks to the current recommendations that would make the variable measured field that much more useful as a mapping and interoperability layer than what we have now, but that wouldn't be the full on, let's solve, variable semantics, across the communities. So I guess I would push for a set of recommendations that incrementally increases the richness of the description, as opposed to trying to come up with an overall solution right from the get-go. Yeah, and I think the folks that are heavily involved in observational modeling might already have a lot of this stuff loaded in their heads, and they want to get all that in there, and it might not be what we need to do. I see a thumbs up from Peter, I think means something, but.
Rock on, Jones from Alaska.
I think you're right, Matt, that there are the same there's certain types of things that could do with a little more help and guidance, and there's other types of things where we're just kind of like, well, here are your options. And I think for when Ruth is coming at this from a discovery angle, I think it's, it would be, if you have this kind of time and it's simple, please do it like this rather than the 17 other ways that you're allowed to in schema.org, right? If you need to put a year in, maybe you could put it in this way instead of some other way, right? If all things being equal, then you might get better discoverability. But if you have other requirements, maybe look at this or maybe look at that. 20 ways of doing things could get turned into maybe 4 or 5 at the discovery level. And if you have something very specialized, go for it, but maybe you can include the simple version too, just to facilitate things for tool builders.
Yeah. Well, I will note that the philosophy behind schema.org, so Dan Brickley, I think, sort of articulates this frequently. And the philosophy is minimize the barriers and work that producers need to do. So basically, lower those barriers so they can get stuff out, and shift that work onto consumers and harvesters that want to use that information. And if there's mapping and synonymies and translation and transliteration and dealing with multiple formats, that's the responsibility of the consumers, not of the providers. And it's a sort of the schema.org and Google's sort of view of web-based, markup overall, right? Is that the web page providers should have very little in their way of providing some structured information.
It works well for them, right? Because they have tons of resources to parse everybody's stuff and figure it all out.
Yep. Okay. Well, so it sounds like, we have more to do here, Kai, on the variable measured stuff, and I'd love to see that move.
So I think we lost you, Matt.
We had the guidelines document.
Sorry, will you repeat what you just said?
Well, I'll try it again. It said my connection is unstable. So can you hear me now? Yeah. So I was just saying that we have more work to do on the modifications to the variable measured proposal. And I think what would be nice to see is like a set of changes proposed for the guidelines document. I mentioned this in my GitHub comment. The document that was produced right now is a good background on the issues, but doesn't really necessarily make specific recommendations as to what we can incrementally improve.
Yeah, I wonder if even if we just started with a simple example out of, I don't know, Kai, whatever you think is best, like Envo and QUDT or UO or whatever that is.
But yeah, like I said, I don't want to push too many things, and that's why I kind of gave that slide. Like for a marine system, like here's a couple of good vocabularies, So it's like here's an example. So that I'm not saying like one's not to use, but that's something like what I was presenting was like, here are a few you could use for a domain.
Yeah.
And I've been trying to come up with these lists, and I know that like people like you, Matt, and Mark, and everyone like knows these lists fairly well. So that's why I've been trying to put those together, and it's just a question of kind of compiling those things, making the iterative. I really like what you said about the iterative little recommendations. I think that's very good.
Yeah, absolutely. Yeah.
Pulling people along.
Sorry.
Okay, well, maybe variable measured can be the subject of the next call.
Yeah, I agree. I think that's a good idea as a follow-on to this. Yeah.
Kai, do you have that? Where are you putting that list together?
I haven't shared it with the group yet. I've only shared it with Steve and Mark, but I can put that out there if you're interested in seeing it.
I'd be really interested because the
Okay.
group that we're working with on the northern stuff in Canada, at least, is working through that and trying to produce similar types of lists, these cross-discipline lists of you know, where to look for your common terminology.
Right. It gets tough because I mean, like with what you're doing, with I don't know if any of well, there might be some on the list that who knows? It's hard to say.
Yeah. But at least if I can find all the people who are making lists, I can maybe find a few things here and there that aren't on one list that are on another. And
yeah, sure.
Be helpful.
Maybe that would be another guidance document about vocabulary guidance that goes along with this, as opposed to making it part of the current dataset guidance. We could have, for certain types of terms, these are vocabularies that might be useful to people, and start to put together that resource.
Yeah, because even among the folks who, as you might expect, our Indigenous elders are not going to be doing any of this stuff. However, even among the folks who are, running data centers full of data coming off of icebreakers, we're sitting down and talking about CF conventions, right? And how to get their data into NetCDF, right? Or whatever, so that it's not just some new spreadsheet format that they made up. And same in the permafrost community. And say, like it's even in our group of fairly sciencey people also, these things aren't totally clear as where they should be going and why, even those types of comparison documents.
Yeah, there isn't like a right answer either. It's like these people did this for this community, it's 80% done. These people did this for this community, it's 20% done.
Yeah. So if there's anywhere to put the list plus any potential pros and cons, or if you want to work with these tools, they work with this, and if you want to work with those tools, they work with that.
So would something like so Matt, you had just mentioned like something like a variable guidance document, and that could be a place to at least start that proto list and just like the list of lists of possible resources that we could enumerate, and then maybe in the future we could pin that, or we could, for a domain, pin a few down. If you're doing marine, use these ones. If you're doing earth science, use these ones, etc.
Yeah, I mean, maybe we could cluster them and then ask the community to contribute. Like, if you're in different disciplines, what are the vocabularies that would be useful starting points for you?
These, I just jumped in here, but you guys are talking about lists of vocabularies that are appropriate for certain elements in certain communities. Is that right?
Yeah, so for things like the property measured field, or for the entity classifications, or for other units, things like that.
Yep, that would be great. And it would be nice if you, in the same place, if crosswalks, however crude or well developed, existed between some of those lists. That might also be an interesting thing for people. A helpful resource.
So you mean like Kai showed an alignment between two nitrate concentration terms and two different ontologies, I think, and that's what you mean, Ted? That kind of crosswalk?
Right. I guess that's a same as tag or something, right? Can you have a thing in one ontology be same as something from another ontology?
Of course, it just depends. Like you have systems A, B, C through Z, and like A and B are mapped, B and C are mapped. Doesn't mean like D, E, and F are mapped to like F, G, and H, whatever. It's like it's some of those exist and it can be done, but again, it's the Wild West of who's done what.
Yeah,
so
and they're hard to maintain.
At least having kind of, I don't know, like that's why the first thing I did was started making that list. So maybe Matt would an appropriate place for me to, could I could make a wiki page on the science-on-schema.org GitHub, and then just have a little description of it there and the link to the Google Drive. I mean, that's a little crude, but I don't know.
Couldn't you just make a markdown page? Like the wiki's in markdown anyways. Can't you make a markdown page in the repository that's versioned and could be parts of releases that way?
Sure, I could do that. It's just that I had it in a Google Doc because it was a bit rough, and it's a little easier for mass editing. But if you want, I can just make it in a markdown.
We can start with whatever's easiest and we can decide how to present it at the end. So
I mean, that's fine. If you want me to, I just don't want it to, like, I don't want to throw something up there that's incomplete and then have people be like, oh, well, like, blah, 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 you know?
Think about 4
Just
minutes
caveat
before
it.
the session starts.
Everything is
That'll just get
incomplete,
people's
Guy.
attention, and then,
All right, so I should just make the wiki page and then be like, just put at the top, like, this is an incomplete list, feel free to contribute.
I can also open
Yeah, I
up-
was going to suggest a Word document, but maybe not.
Well, that's what it is now. It's a Google Doc now, so.
We'll defend
Just
your
kidding.
honor.
Just kidding.
The nice thing about putting it in as markdown actually in the repository is that you could, have pull requests, a little more easy to see where it came from. I know the wiki is also
The
that,
wiki is
but it's
even
hard
easier.
to
You
get.
even need a pull request. You just edit the page if you have access.
Yeah. So I think that's good. The versioning and the merging and all that kind of stuff, depending on whether people need to go anywhere before they make the change or take it somewhere and make changes. But anyway, it's fine, whatever.
Yeah, right now only a handful of people have edit access to the wiki though. So I think that's the bigger challenge is that
Right, which is
we can
why I was suggesting like just make a wiki page about it linked to the Google Doc and then just have that be open access, I guess.
Sounds good.
Okay, I can do that.
Well, it sounds like the plenary is going to start here in a few minutes, so we should probably wrap this up and plan on picking up on the next call.
Yeah,
Dave,
thanks a lot again, guys. It was a really interesting session.
Yeah, Dave, I really liked what you presented too.
We like Dave. Dave, we gave him a chance to present in the earlier session, and then he reused it in the next session. It was great.
I wanted to mention that you talked about Crosswalk, Ted, and I know you're big on the ISO stuff, but just before you disappear, in case I don't see you again, some of the stuff that we've been working on is actually a tool to, was working with Doug's Gleaner, but then converting it to ISO. So taking schema.org, harvesting it, and then actually doing a conversion so that it could be served up using catalog services for the web or something, and then fed into something like a CCAN or a network.
Amos, I knew I was going to like you. I found someone that's converting from schema.org to ISO. Yeah.
So just so that those folks can participate with the fancy tools.
Yeah, just so that you know, Amos, I'm not really that big on ISO. I just mentioned it to bother people in this group.
I'm sure, and it seemed to work.
I did write a bunch of it, but yeah, it's mostly just fun with old friends. You're new here. We're glad that you're here. You had some really nice things to say today, but a lot of us have been giving each other shit for a long time.
Yeah. Okay. Well, good. I'll try and jump in and do that too.
Yeah. You're
Glad
welcome.
we got that on the record.
You're welcome to join that. That we have the shit giving cluster, but it's a secret URL.
Yeah. Okay. When I've earned it.
Yeah. Okay. Talk to you later, guys.
Bye, everybody. Thanks.
See ya. Thank you very much.